All right, start it.
Okay. A few months ago, or last month, I often tweet flame bait against different technologies. I had been playing with Akka's futures, unfortunately in Java, that day, and I was a little frustrated with it. And I had been playing with Java 8 for a long time, and so I tweeted this kind of incendiary comment. And so we got to talking, and we started talking with Zach about, maybe it'd be a good idea to have a presentation where we kind of talked about the new stuff that's in Java 8, talked about the functional programming aspects, how they might compare and contrast with Scala's, and also maybe from Scala's enthusiast point of view, like what are some of the underlying JVM changes that might make Scala better, and how might it all play into Scala. So I had done a presentation for CI Jug, Central Iowa Java's User Group, about a year ago, I think, on the future of Java 8. Kind of solidified since then. That was before it was actually out. It came out officially in March, so there's been a few changes since then. And I've updated this presentation. So we'll give this presentation just to kind of show where Java's going. We'll talk a little bit about some of the concurrency stuff that and the future stuff that's in Java 8. Talk about how that might impact Scala, and then Zach's going to cover kind of from the same ideas. How do we do those same things in Scala? And we can talk about which one's better or worse, or which ideas could borrow from whichever one. So
let's all be nice and not troll other languages.
Right, except for Perl. You could say whatever you want bad about Perl. There's no Perl people here, and even if they were here, we would make fun of them until they cried. So point of Java 8 almost entirely is Lambda expressions. Most of the actual underlying concurrency stuff actually exists in 7, but it's really kind of hard to use and still kind of awkward. And so Lambda expressions and some of the stuff they've built into this, particularly the streams API, is really what the point of Java 8 is. From a language standpoint, from a functional standpoint, Java 8, what they're really trying to do is making multiple processing available to the average programmer. So we have lots of cores available to us, but a lot of Java programs don't take advantage of multi-core. They're on single threads. So you guys probably all know this. It's kind of designed for people who never encountered a Lambda expression, but you have them in Scala, so it's an anonymous function or subroutine defined, possibly called without being bound to identifier. Except in Java's case, they are kind of bound to identifier, but you don't really know that. So why add them to Java? There's user demand. People have been asking for them for years. They first considered them like 10, 15 years ago about adding them. There's been an explosion of functional paradigms in Java. In Java itself, Guava, but then also with competing JVM languages like Scala and Clojure. And so the Java teams felt that they needed to, partially do this just to stay relevant. Like if we don't start to embrace some of the functional programming aspects that everyone else is starting to take advantage of, it's just going to get left. It's going to be the next COBOL. And so what's wrong with existing Java? It has bulky syntax, which people have been fighting since Ruby. Confusion surrounding meaning of names and this. Inflexible class loading and instance creation semantics, which are heavy, which probably adversely impact Scala, I imagine, underneath the covers. So the answer is everything is really based on this idea of functional interfaces. A functional interface is an anonymous class with a single method, or an interface single method, could be either one. They're originally called SAMs. If you start reading up on some of the beginning documentation on this, they were called SAMs. So they have not broken with the idea with the base JVM. Base JVM is still, for the most part, the same base JVM. And everything still has to be an object, and the object model in the JVM still closely relates to the class model of Java. And so by doing this, by using anonymous classes with a single method, it fits into the existing JVM type system and fits into existing Java very well. There are no new keywords involved, and it fits into all these existing libraries. So we have a common pattern in Java with callback handlers, where you pass an anonymous inner class that wraps generally another method in the class. And so the way they've done Lambdas fits into that well. So now everywhere where you were doing an anonymous inner class with a class that only had one method, you can now transform that into a Lambda expression. And in fact, IntelliJ, if you're using that, has had very good support, refactoring support for this for a long time, since the very beginning stages of Lambdas. And now it'll actually gray out an anonymous inner class, and you right-click on it, and it says convert to Lambda. It just folds it all up. In fact, it'll actually do that for you. If it's still an anonymous inner class, it renders it as a Lambda expression and puts a little squiggly line saying this could really be a Lambda expression. So, example, functional interface. Here's the old runnable. This is a very old class in Java, which just runs something that you pass to a thread. And so our new one is that. So another example of exactly everything we're getting rid of. So we can basically get rid of the new, get rid of the name of the class, get rid of the override, get rid of all of this stuff, keep the name of the variable, get rid of the return, keep the meat. So basically the last line in your Lambda expression inside this method is a return by default. Get rid of that, keep the semicolon. And okay, that. And we'll actually get rid of this guava stuff even later. So functional interfaces are defined as T is a functional interface type. The Lambda expression has the same number of parameters as T's methods, and those parameter types are the same. And each expression returned by the Lambda body is compatible with T's methods return type. So it's doing all of this through just the inspection of what should be in the thing. So thread run takes a runnable. It expects, of course, the Lambda expression you're writing is runnable, because that's the thing that it's expecting. So this is a big, something that really differs from the way Java has traditionally been. Java's always kind of erred on the side of we're going to be super obvious about everything and be very declarative. And now they're finally doing some kind of guessing. So there's a number of different kinds of Lambda expressions that they have that you'll find in the Lambdas package, in the functions package. And these are really just interfaces, and they don't really have any implementations. It's up to you to provide the implementations. The main one you'll find is function of E to U. So takes the left, returns the right. Easy. We'll get a long for 2. Consumers consume stuff. So they return void and accept something, probably good for sending messages, for example, where you don't expect anything in return, you're just sending it off somewhere. Predicates used for filtering, mapping and such. So it's going to has a method called test that's a Boolean and returns our expression. You'll note that the Lambda hash rocket uses a minus sign rather than the equals like Scala and C#. The reason for this is so that it didn't get confused with equal than or greater than, was the excuse I heard. And there was also jokes on the message board that they just wanted to piss off Scala. So Scala, there's a lot. I started following the Scala or the Lambda developer group, or the developers who were writing all of this and communicating. I started following it a couple years ago, kind of when it first started heating up. I would just read it every few days. Scala is probably one of the major influences for how they wound up doing Lambdas. Probably between Scala, Guava, which isn't, doesn't have Lambda expressions, but is a functional kind of thing, and C#. Those were like the three main things that they were considering, and they would talk about, well, C# does it this way, Scala does it this way, how do we want to do it? Java developers who are doing functional stuff already are used to Guava acting in this manner, so maybe we should do it that way. And by the way, the Lambda stuff plays into Guava really nicely. So if you're already using Guava in your program and you just want to start introducing Lambdas into it, it's really smooth. So suppliers supply an object. They're just going to return foo. And there's a bunch of others. There's bifunctions and binary operators and unary operators. And then you'll find that there's specialty classes for primitives for just about everything. So wherever you could get into a situation with primitives, you'll find there's a double consumer and an int function and a long function. And they don't provide short ones, but any of those primitives.
Is that just to get around autoboxing?
Yeah, partially. It also does some really nice things where, when we get into the streams, where there's some additional functionality they've added on top of. Like if you have a stream of an int stream, that you can do mathematical stuff on it without having to do any casts or anything. You could just say, I want the sum of this stream. And the sum is just a method already on it. And it knows that it's a numeric one. But autoboxing was a big concern for it. Generally speaking, you can chain these together. So in this case, we have a unary operator to begin with. And I'm just going to do and then compose and apply. And with that, so you can start to kind of get some monady kind of composition. Life cycle, I get the slide to this because I'll jump over. So Lambda expressions do differ from anonymous interclasses in a couple of key ways. They are lighter weight than full classes. You don't get a true full class instantiation with Lambda expression. And this fits in with the JVM. The JVM says that a new object, like even the new keyword per JVM, could return either a new version of the object or it could return an existing object. Not many JVMs return you the same thing every time for new, but it is actually allowed. And so Lambda expressions always return the same thing. So once you've got it once, you get the same JVM, you get the same Lambda expression every time. So, which doesn't happen with anonymous interclasses. So down here I have a supplier that this doesn't have it. Oh, see, here's IntelliJ being sneaky. So we have a method that returns an actual anonymous interclass, and one that returns a lambda. They do the same thing, and you can actually run these. And the anonymous interclass, every time I call the get Lambdas supplier or get anonymous inner class, these aren't the same object. They'll always be a new and different object with a different object ID, but the Lambda expression always returns the same one. The Lambda expressions also are more limited than their anonymous inner class. They have more restrictive access to the classes that they're in. They are actually a member of the class, but they can't do full things. In fact, if you look at, so when we talk about lexical scoping, I think actually the next slide on that is what we're doing. So in this case, we have 3 runnables. And runnable 1 sysouts this. Runnable 2 does a toString. And runnable 3 is an anonymous inner class and does toString. And toString prints out. toString within this class returns hello world. Both of the Lambda expressions will return hello world because it's a member of this class. It is part of the class. Whereas the anonymous inner class will return its class name, its object ID, because it's actually a different object than the class that it's in. Whereas the Lambda expression is really a part of the class that they're in. So this is where something that Scala, I think, could probably take big advantage of, and that I imagine, and those of you who know more about Scala than I do, then please speak up. That much of what Scala is doing in the background is anonymous in their classes. And so you wind up doing new a lot, and so you wind up with a lot of garbage collection. And this kind of circumvents that. Maybe Scala has a magical class loader that is returning the same thing over and over. I'm not sure. So we'll just talk briefly about multiple inheritance in Java. Not sure how much this will affect Scala or not. So the Java teams wanted to extend collections, wanted to be able to basically add to interfaces that they already had without breaking everybody. So they needed, for Lambdas, we need to add like toStream to all of the collections, but it's actually just stream. And they don't want to break the existing code bases. So Java now has default methods on interfaces. So this is the actual interface for iterable, and it now has a for each method on it. And that for each method is implemented. So now, when you upgrade to Java 8, you don't have to go and change all of your classes where you implemented iterable by yourself. You already get for each method. Those for each these default implementations of methods can't have state at all. They have to be completely enclosed.
They basically look like Scala traits.
Yeah, I don't think it's quite to that level, but yeah. This brings in the diamond problem. So I can have class A, B, C, and I can have, and they each implement their own foo default interface because you can override them. So then I implement D that both implements both B and C. Which foo do I get? So here's that example. Classes, if you try to do that, you'll get a compiler error that class D inherits unrelated defaults for foo from types B and C, and you will have to resolve that by overriding it and saying which one you want. You got to pick one. And I'm saying, I'll take B. I'll get into collections. So the big thing, more than futures, there is a futures interface, and I'll kind of show that, but they're not really pushing it hard. It's kind of like in the background. I think it's used under the covers in a lot of the stuff, but the Java teams are really pushing streams as the way to do functional programming. And a stream is a sequence of elements supporting sequential and bulk operations with no defined start or end. So you could hook them up to like WebSockets. A WebSocket could return a stream. Once a stream is consumed completely, it's done. So here we have a stream of 2, 3, 4, 2, 3, 5, 8, 15. I'm going to filter to those that are less than 5, and I will get back 2 and 3 of that filter. So again, this is our example from before with iterables. This is a guava function, and now we can basically write it like this. So we're going to get all the courses and filter them by an expression. So we have filters, we have distincts, we have sorting. We can distinct and then sort and then filter, all in one. Here's another example of sorting off of 2 things. And if we have, so this of is static off of streams, and since we're giving it ints, I'm getting back an int stream in this case, so we're talking about map. So we can do max and min, and we can compare them. So we have a stream of integer. Well, this is just a stream of integers rather than an int stream. Series of numbers, and we have a all match, any match, none match. We can slice our streams. We can create substreams. Limits. We can take a substream and just part of it with a start and an end, or just start after 3. First any, which any will return probably 1, but it's not guaranteed. In this case, you could be anywhere in your stream and call any. They also have introduced their own optional, so obviously everyone in Scala is probably familiar with optional. We can do the same things, ask it if it has value, get the value. There are functions for doing things if it's present or if it's not present. And here are some collectors are, you can normally do them at the end of the stream. So we're going to iterate through our stream, and then we want to collect all of the results and do something with it. Usually, you might, if it's strings and you want to concatenate them, that's what this joining collector is. That also takes a delimiter. So if I wanted to make a comma-separated list or something like that, we could also have collectors for lists and sets and all of the different Java collection types. There's a bunch of new stuff with maps. So now maps can do things like compute if absent, compute if present, and just compute, where we iterate over all of the entries in the map and do something to them. And merging and replacing off of the map. So if I want to replace particular keys or values, there's functions for doing that. I can do that all in the expressions. And then this all feeds into MapReduce interface they've introduced. So in this case, I have 2 users, Ryan and Dan, and I want to just get our names back. So I can take the stream, or take the map, and map it into a stream of strings. Point back to Ryan and Dan. Now I can do basically I can do the same thing with a map of maps. and flat map it and get back the same result. And then I can reduce it with a function. So take all of my names and add them together, and we wind up with Rhindan. And oh yeah, and then you can also, this basically, that is the same as this, which is, this is a method reference. We'll start to see them. So if you have a method that takes so this is one, there would be one thing on the left side, or the left side, or x. So as long as the x, either the x is the one that it takes, depending upon what kind of function you're doing. But generally speaking, getName doesn't take anything, and we have an x, so we can just reference the user.getName. So we're saying this is the method we're going to call. I'm not really. There's some times when it actually, I mean, that doesn't really save you all that much more than that. I don't know that it's all that more readable. Or there are other examples where it might make more sense, especially when you're dealing with the class that you're in, and the function is more complex than like this example. So here's an example of grouping. We have a stream of people. And we have these people live in different cities. So Des Moines and Denver. And we have 4 people, 2 Nancys, 1 in Des Moines and 1 in Denver. And we're going to collect all of these people grouped by the city that they live in, and then mapping their last name into a set. And we're going to get back. Des Moines has Nancy and Brian, and Denver has Nancy and Paul. And then if we want to do that in parallel, we just add parallel. That's really the magic sauce that they're pushing, is that if you want to take care of parallel processing, you want to make use of all of your cores, you're already doing the stuff in streams, you just add .parallel, and boom. It'll use the default thread manager, or it's the default caching manager, which means it's not going to dedicate all of your threads, all of the threads it can. It's not going to hold on to them forever. It will use them as it sees fit, and release them if the system's not using them, and it'll reallocate them. And you can use up to 1 thread per processor. So if you have 4 cores, minus 1, because you have to minus the one that you're on. So if you have 4 cores, this process takes up 1 thread. You can consume 3 other threads through .parallel. Are there any questions up there? I've gone really fast through this. And yeah, that's release date. Sorry, passed.
IntelliJ is cool with all this stuff.
IntelliJ is very cool with all of it.
Very helpful.
It understands most of it. It'll show some more examples in here. This is all on GitHub, and most of these examples are up there. So I have an example where I went and downloaded from Spotify some JSON files that list out. I only got 1 page each, but you get back all of the tracks for a particular artist. So I got some of my favorite artists. So I got David Bowie, Gary Newman, Information Society, Kraftwerk, and in parallel, I'm going to take them. I'm going to map. I'm going to basically download this simulates. I wasn't sure if I was going to have internet access, so this could have been for actually downloading it, hitting the Spotify URL. I'm just assuming go in here and look. I'm just loading these JSON files out of resource, but this could be just as easily hit the URL. So first, download the files, and that's going to give me this artist record. So in here, I'm also serializing. I could have broken that out into actually a separate step of transforming the JSON back into a class. And then I'm going to do this map to double, which means this needs to return a double. I'm going to take an artist return a double. And this actually does some stream stuff itself. Takes all the tracks, transforms them into a stream. The popularity is a string, so I'm going to parse it into double. Then I'm going to get the average of all the popularity of each track, and that returns an optional level. And then I'm going to actually return the value of that, I'm just assuming that it's going to have one. And then I'm going to average all of those doubles. So I'm going to get the average of the artist, and then go up with the results. See what it returns. So the average of everybody, and they're all like 20 something, so it's not that bad. It's 31%, what it comes up to. And that was all done. Each of these were done in parallel, I believe. This part is done. Everything would be done in parallel up until you get to here. Once you hit that average, it has to wait and collect everything and put it back together. That's the nice thing about the nice thing and the bad thing about the streams is that you can, utilize a lot of this stuff for doing stuff in parallel, but you don't have a lot of good view into exactly what's happening. It's all just kind of magic.
Have you found a way to verify that the extra cores were being engaged?
I did write a test that I lost it when I reformatted my hard drive, but where I calculated prime numbers and then put in some weights. So depending upon like one number in it, whether it was like a mod of 7 or something like that, I basically made it wait an extra 100 seconds, and you could watch all the cores fill up with it. I also had this, but I don't have a really good example. I don't have my logging set up. Last time I did this, so it's I haven't downloaded multi-tail. So this is doing FizzBuzz. So basically, you can generate a stream. You can just generate a continuous stream. So I have a function that basically takes a number, takes a counter, and increments it. And this stream will run forever. It'll never stop. And then in parallel, for each thing in that stream, run this FizzBuzz method. And FizzBuzz does the FizzBuzz test. And if it's a mod of 15, it puts it in both fizz and buzz. And if it's a mod of 3, it puts it in fizz. And if it's a mod of 5, it puts it in buzz. And you have multi-tail. You can fire them all up and watch all of them going at once. And they'll also not be in order. So at the very top of them, you'll start out with 3, because that just happened to be the first one through, rather than 0. So they are being done asynchronously. They are being done in parallel.
Does it synchronize on the iteration?
On generate?
Like that increment and set isn't an atomic thing, right? So
I think it just keeps calling this lambda over and over and over again.
yeah, but if it's doing that on multiple threads, not a.
It's not on a multiple. This part isn't on a multiple thread. This part is.
Okay.
So this is the numbers is on the calling thread, where it sends each of those numbers that's coming out of it. Those are going on different threads. That's after the parallel.
But I mean, is it are those threads pulling from that generate, or is that generate just generating? Because it's no point in generating things that nothing pulls from it, right?
I'm not sure. I don't know if it'll. I guess we can go
the Java
with
string
the.
is lazy, so it's the
Yeah.
for each that's pulling
Yeah.
out of that.
I guess it doesn't really say like what's triggering it. I don't know if it like recalls supplier after one is consumed and it only has like one thing in it at a time, or what. That's a good question. there are these splitterator things in there. I haven't quite got my head around how to use those well. But supposedly they're supposed to let you intelligently split streams. But then if you read the documentation from the Java guys, they don't really want you to do that. They explicitly say at one point you shouldn't split streams and have them be consumed by multiple things.
I thought the splittrators really only meant for people that are writing their own.
I don't think they're meant for mortals. They're in there, but they're not. Somebody will use them. Whoever writes Scala will write it. I'm sure. They're used all over. When you get into their source code, they're all over the place.
Yeah, I mean, if you were going to implement stream, you would need to use them.
Yeah.
But if you're not actually implementing your own stream, then I don't think you can do that. You can kind of ignore it.
This shows, just for fun, how lambdas actually get generated, sort of. This is kind of a static version of the way they're getting. So what you don't see here, and what you don't really have access to from the Java side, but if you were a JVM programmer, you would have access to, is a method called invoke dynamic. So there is an invoke dynamic that was added. It's in Java 7, and it was designed for some of these other languages like Scala, like JRuby and stuff that needed to dynamically invoke code. And there are examples where people have, I've seen examples, I don't know if they're public yet or what, where you can actually like write Ruby directly into a big string inside Java and then pass it in, and it'll get actually invoked, as long as it has some kind of runtime so that it knows how to invoke that. And Java's not like coming with any of that by default, except for whatever small one that they wrote for Lambda expressions. The Lambda expressions are getting invoked at the end. Basically, at this point, this thing called Lambda metafactory. And so in this example, you get a method handler, which in this case is the method that I'm in, which is this main method. Then I'm going to say I want to create a method that has void as a return type and is a runnable. And so from the Lambda expression, it's coming from me, and that's like a name, and this is the type of the class it is, and the return type. And then off of me, I'm going to find this static method, which is say hello. But this would be replaced by the call to invoke dynamic. And then again, T. And so then that gives me back this method handler, and then I can basically I can say, well, that's runnable, invoke it, and we'll just run that. So this is actually kind of what's happening under the covers, other than that I couldn't figure out a way to really show you invoke dynamic, because they kind of buried it down into the JVM. Or at least there's no clean interface to get to it. And those are, so it's up to the JVM throughout the life cycle of these. When I said like you get the same one back every time, that's what's happening in the Oracle JVM. It's not necessarily guaranteed to happen in other JVMs. So if you're using IBM's JVM, who knows, for whatever reason they decide to do what they do, but it could potentially do something different every time. But the Oracle one behaves this way. That's the same example before. I guess that's all I have, unless you want to see anything specific or ask any questions, or then we can get over to the Scala side.
That average function you had, why wasn't that parallel? I didn't see.
Because this one?
Yeah.
Why isn't that one in parallel? Because it's got an average. I guess I was assuming that it's not, because I believe it has to wait for all of the doubles to come back to be able to calculate the average. But maybe there's some kind of black magic way it doesn't.
There is, well, I don't know the average, but like in a normal MapReduce, what you do is instead of computing averages, you compute sums and counts together,
Right.
and then you'll chunk those together, and at the end you come up with total sum and the total count of everything. And you just provide your
I guess
averages.
it could be internally, it could still be parallel, and then until you actually want to get the actual result, until you get to that point. At some point, you have to wait for everything to finish, get an answer. But this is just the optional, so I don't think it would happen there. Yeah, it's just an optional. So it might, it might be parallel up to the G.
Well, like if you want to implement something like that, I mean, just have like a monitoring interface or something that you can make it if you want something like that parallel, or.
Oh, so I was also going to show the futures. So there is a thing called completable futures. Again, I said this isn't something that they're really pushing. It exists. You can use it. There are very few websites right now or blogs where people are really explaining how to do this. And then a lot of them say, you know what, you can probably do most of the stuff you're trying to do here with streams, and it might be a little bit easier. But so completable futures is probably a little bit closer to what you'd see if you were using Akka futures. And it provides you much greater control over the composition of what you're making, which is really, this is kind of their interface for monads. And so, I started to think, how can I explain monads? And I think, oh, they're Scala developers. I shouldn't have to do that. But it's like you have a bubble, and inside is some stuff. And you can put some more stuff in the bubble and add to its function, and then get back other bubbles. So like a lot of monad stuff, it's really nice. It's really fun to like make the bubble and make the stuff happen in the bubble, and it's a huge pain in the ass to get it out. So in this case, I'm doing the exact same thing I did in the streams. I have a completable future of doubles, and so I'm going to take my artist array of strings. I'm going to stream those. I'm going to map them. I'm going to download site. I'm going to map that into. So this map actually returns another completable future, which I can then compose with the next method that I want to do, which is supplying asynchronously again the relevance. So that's going to get my average of averages, and then I'm going to collect that into a list. Now what I have is a list of completable futures of doubles. By the time you get through with this, nothing's actually happened. It's probably none of these files have even gotten touched yet. I had to add this sequence function to kind of re-glue them into, because there wasn't really a good way to do that. So what I really wanted, rather than a list of completable futures, was completable future list of doubles. And so inside there, I kind of reversed that. I totally ripped this off from someone because I didn't know what that was doing. And so kind of resequence those, and then take those relevants and stream them, and then map them to doubles, and then get the average. And I wound up with basically, should wind up with the exact same answer. Except this one does a lot more things in parallel.
More reactive.
Right. It's also a hell of a lot harder to read and understand. But you get in a situation where you really need that control. And if you crafted one well, you can place it into a stream and process that stream. So, that's it. You want to come up and take over yourself? Are you raising your hand, or we just start on that? Oh.
We'll have a 2-minute intermission.
Yeah, it is just at the other end of the hall. There's a gym right there at the end, and you can use your badge to just stand over there. I think there's a bathroom there. There's a women's bathroom down there too. But,
There's no bathroom in the gym though.
yeah.
The song stuck in my head all day.
Mr. Steak.
I'm a little tricky with that. Yes. Oh, here.
I'm curious, do you know how many people that use Java at all, sometimes, or?
I would guess. So there's some percentage of the group that just always uses Scala for the day job.
Sure.
And then the other, so you could split it into two. Or the other group is probably mostly on Java as day job, like
Yeah.
just in Scala.
Yeah.
If I had to guess, I'd say that's maybe like 50-50.
Yeah.
It's definitely not like there's 1% of the group that's Java developers.
Yeah. Okay.
But there are
I would really encourage me after you guys were thinking that's a good idea. Apparently, this is really good shit. I'm gonna be.
Yeah. It's really interesting. It's being a Scala developer. I vaguely knew what Java 8 was doing, but I kind of heard Java 8. Java is going to get linked with Java 6 and then Java 7.
Right.
So I'm like,
Yeah.
doesn't really affect me. But it was interesting kind of diving into it.
Yeah.
I can tell it's been heavily influenced. A lot of it is similar. But then there's some major differences. Which may related to the invoke dynamic depending on JVM, like code that gets generated.
Yeah. Sure.
Between the two, just got to review the same thing.
So were there actually JVM modifications for Java 8?
Well, they added invoke dynamic to Java 7. Well, it's with JVM for Java 7, but Java.
No, I brought it for you.
And I don't know what the other JVM languages, like Jruby, Ruby, using both of them. As a Scala.
Well, that's because you were
No, I mean, because
Jruby.
not.
Yes, they're both.
I remember
They're both
both
used
a couple of years ago that was talking about like
Well,
which one the language I was
There's a really great blog post by Charles Nutter, the JRuby
Okay.
lead developer. Where it's blog post, I think it's from like 2000
Yeah. Okay.
now, but he went through a whole long spiel about how this would help JRuby.
Yeah.
So it's definitely JRuby.
Yeah. Could be.
JRuby will finally get the attention it deserves. Jay loves JRuby.
Does Jack Henry have the?
It's like 20% off.
Yeah, it's definitely fun to
Go on prepay
kind of dive into like it's not like something you want to do on a day-to-day basis.
Right.
Same with bytecode.
My wife doesn't know that yet, but we'll see. Probably end up,
Well,
Yeah.
she'll probably end up on something else.
Okay, so I'm Zach. I'm going to kind of do the Scala side of this. Again, it all started from a tweet. It's amazing the things that can start from tweets. I was kind of surprised after Ryan tweeted that. No one like jumped down his throat, said like, F Java, Scala rules, or, you know, yeah, there weren't no flame wars. We just got an iascala top out of it. So. So my original goal was to take all the Java code that Ryan wrote and translate it into Scala. I didn't get that far. I did write some code, and that's primarily what we're going to look at. But if anybody wants specific examples from Ryan's code rewritten into Scala, we can just live code that. So remember the code that Ryan showed, and if at any point if you want to see anything, we'll just do that. So the purpose of this, Java 8 now has Lambdas and some better concurrency tools. How does this compare to Scala? Because Scala has kind of had a lot of this stuff that was a major part of why Scala exists, is to add things that Odersky thought were not in Java. Make a better language. And then, so look at the Scala level of things, and then I also didn't get a chance to go as deep into the JVM changes and the internals of, you know, the bytecode that gets generated from the Java and Scala side, but we can touch on things, and I'll provide links to a lot of other resources. The great thing about Java is that anything in Java has like tons of blog posts and forum posts and all kinds of stuff about it. So any of these keywords like, you know, Java 8 lambdas, invoke dynamic, you can just do a Google search and read for hours about these things, which is a little bit different from Scala sometimes. Yes. Yeah, so code examples. So all of these code examples use Java 8 as the underlying JVM. They use Scala 2.11. I made a GitHub repo, which is not fully updated yet. I also posted a link there to the GitHub repo for Ryan's code. We'll try to get these slides up somewhere eventually. As just kind of a side note, the way I did this code was just a little funky. It's kind of fun. Because I don't use Java 8 for my day job, and this is my day job laptop, I didn't want to mess around with like installing new JVMs and stuff, because that's not a lot of fun. I ran a Vagrant with Ubuntu 14.04 and put Java 8 on that. Vagrant is a really awesome tool. I probably should have used Docker, right, Lou? Um,
For the beer.
I don't know it as well. But I can edit source code over here on my local file system, and that gets mapped to a directory on the Vagrant box, a SSH in there, /Vagrant is mapped to my local OS 10 directory, so I can just run SBT over here. Better. That bottom line is really important. And I can set up my compile loop. I have Java and Scala source code in this one project, and SBT is compiling both on the fly. So just a fun little aside there.
One note, go back to your screen before. See that where it says warning ignoring option max font size? 256. I believe that's because they got rid of permit in Java 8.
Really?
Yeah.
That's cool. Yeah, so that is proof that I'm using Java 8. So does all that stuff just get put on the heap?
There's a separate space called meta memory. It contains much of the same stuff that permitted before, but it doesn't contain the strings anymore. And it grows dynamically over time.
So I won't get out of memory error meta.
Until you actually run out of memory.
Okay. That could be a whole other iascala talk. Okay, so just to kind of start out, here's some Java code. This was a line from one of Ryan's slides. So this is creating a runnable using the new Lambdas syntax, which looks really nice. Aside from the equal sign versus the dash sign, it looks really similar to Scala, I think. I hadn't really dove into a lot of the new Java 8 changes, but in preparing for this talk, I did get into it, and I can't troll Java on that stuff. As a Scala developer who trolls Java a lot, it was like, yeah, good job, Java. So how would we do this in Scala? Well, a first attempt is this commented outline up here. We just, do val run. It's of type runnable. Can we just assign it to some function-looking thing? No. So, there's definitely some special voodoo the Java compiler is doing, and it's kind of related to this functional interface stuff. Screen's kind of cut off. Another side. I would encourage you to go and read through the Java 8 Java docs on these things. You basically will see this functional interface annotation stuck on a lot of things, like runnable. The runnable interface is now annotated with functional interface. It basically says functional interface, well, it's an informative annotation type to indicate that an interface type declaration is going to be a functional interface. So that's how, if the method, if the argument types and the return type match whatever you're trying to do, Java compile will just kind of magically let you do a lambda thing there. Then this is an interesting paragraph. However, the compiler just doesn't care. If things match, it doesn't need functional interface on it anyway. So I thought that was funny. Nobody else did.
It's all the Java view, not the Scala stuff. The Java language package.
It's where are the functional classes?
Yeah, all the different things you would get.
They're all in one package. They're in a functional package or functions package.
Java.util.function.
Yeah. That's why I wrote all those tests. I just opened that package and like started clicking through and say, well, what does this one do? What does this one do?
Okay, so how do we get this kind of nice syntax in Scala? Because we can't let Java beat us, right? Okay, so here's like the next. This is kind of the basic thing. We can just do an anonymous, inner class here. We can do up a new runnable, override def run. We can do whatever we're going to do in there, but that's too much typing. This doesn't really relate to Java, but we can make an implicit here. So this implicit will take some function f, which doesn't take any arguments, and unit means it doesn't return anything. And so this method, function to runnable, takes one of these functions and returns a runnable, a new runnable object. And that is just basically what we did up here. Now we do it here. So the implementation of the run method just calls this function f and does whatever side effecting operation that f does. Hey, now we can. Now we have nice syntax. So run2 is of type runnable, and now we get our nice little syntax, thanks to Scala implicit. So a lot of this is just kind of like down below here is just review of the types of things you can do with defining functions in Scala. There's also sort of a subtle difference between methods and functions in Scala, which can become a rabbit hole of a conversation, but I think the TLDR is do it is a method because it's like kind of a member of this object, but other things like this val here, this would be a function because it is kind of its own thing you can pass around. It's a great Stack Overflow post if you want to waste an hour or so. Difference between method and function in Scala, so go read that. Okay, so we're defining this method doIt. Takes no arguments, returns unit, just does some stuff in here. This pretty much has the type we're looking for up here, right? No arguments, returns unit. So I can use it to create a new runnable here. This little underscore, which we love in Scala. More or less what it's doing is converting that doIt method into a function. And then, because it's a function, our implicit can create a runnable for it, and we have a runnable. So that's kind of an example of like converting a method into a function. The next example, doIt2. This is doing something very similar. Now we have a value called doIt2. It has its type is a function of no arguments to unit, and its body just looks like everything else we've seen. We assign it to this run4, which is a runnable. Because it's a function with the right type, the implicit conversion will convert it into a runnable. doIt3 is essentially exactly the same thing as doIt2. We just omitted this type declaration. Scala type inferencing, smart enough to realize takes no arguments, doesn't really return anything, so it's unit, so we can do the same thing. Here's a real verbose example of kind of what doIt2 and doIt3 are really doing under the scenes. They are newing up an object of type function0 with unit as its type parameter. So the way functions really work in Scala, they're all instances of these function classes. Function0 means it takes 0 arguments and returns unit. Inside, there's this apply method, just like on the Java side. And we are saying that our apply method, just does do it. So I can assign that to runnable in 6. And then slightly briefer way of writing that. We still have do at 5 is of this type function 0 of unit, and there's our little function literal, and we can assign that to run 7. Any questions so far? But lots of different ways to do basically the same thing. Okay. So some other function stuff. Up above those were functions of no arguments. We can have, functions with arguments. Those are useful. F1 takes a string, returns an int. F2, basically the same thing. Takes a string, returns an int. F3, same thing, just written a different way. Now F3 is an instance of type function 1. Takes a string, returns an int. Kind of making things, adding more arguments. Now F1 takes 3 integers and returns an int. Another way to write that, the type takes 3 integers and returns an int. Or, that's basically of type function 3, which means it takes 3 arguments, 3 ints, returns an int. So I thought it would be fun to kind of write some Java code that does similar things. Just see how you do this in Java. So here, F1. So again, this is Java. Java has this function type, which is sort of the same thing as function 1 in Scala. Go look at the Java doc. It's an interface called function. It has 2 types, T and R. So T is the argument type, and R is the return type. And then if you look at the methods, it has this apply method, exactly like Scala. Takes a T, returns an R. They have nice little functional things for composition and then and compose, just like Scala does on its function traits. Has an identity method also. So if you wanted to write a higher order function in Java called F1, this is how you could do it. You could say my F1 takes a function, takes a function object, which is a function from integer to integer. This is just a stupid implementation of this function. It just calls f, passing value 1 in, and returns whatever f returns. Okay, easy enough. Now, what if I wanted to take a function that took 2 arguments, both integers, and also return an integer? Java provides a by function interface, which it's just like Scala's function 2. Again, this just calls apply on that function, passing in arguments 1 and 2, just returns whatever it did. Okay, so now how do I do 3? How do I take a function that takes 3 arguments? Well, I just wrote this hoping it would work. There's no try function in Java, so too bad. But not really. Scala provides those function traits up to function 22, I think, 21 or 22. So you want 23 arguments. Too bad. You should just refactor the code. Okay, so one way to kind of get around this, I know this is kind of a rabbit hole down. If you guys don't care, we don't have to talk about this stuff, but I thought it was interesting. So one thing you could do is kind of pass in a series of functions to this. So now F3 is taking a function that takes an integer as an argument and returns a function. That function takes an integer and returns a function. And that function takes an integer and returns an integer. if you come from Scala, you've seen this a lot. Then the implementation just takes that function, that overall function, calls it with an argument of 1. The function returned by that, we call it with an argument of 2. The function returned by that, we call it with an argument of 3. And it's essentially the same thing as this. And that actually works. So we'll kind of skip over some stuff and just look at how we call those things. So remember, F1 took a function of 1 argument, 1 int, return an int. So this is the little lambda function that we're passing into F1. Just returns its argument. F2 took a function of 2 arguments. So here's our lambda for that. A and B are the 2 arguments. We just return A plus B. This was my original try at using this. Or no, sorry. This is my original try at calling this thing. Yeah, 1 argument, 2 arguments. Hey, maybe 3 arguments will just work like that. Nope, didn't work. But I can do this, which looks really similar to stuff you would do in Scala. So now I have A is a lambda. This is a lambda that takes A, and we're returning another lambda that takes B, which is returning another lambda that takes C, which is returning A plus B plus C. I thought that was pretty nice that you could actually use that syntax in Java. So good job, Java. Another thing that I managed to do, I just defined my own interface here called my try function, which has 4 type parameters. And I'm just basically saying what it extends is basically this monster up here. Function, which returns another function, which returns another function, which returns an integer. So I'm kind of just renaming this big thing. Then this f3b function takes a my try function and just does the same thing that we did up here. F3b works exactly the same syntax. So that was kind of cool. Then in a Stack Overflow post, someone gave an actual implementation of try function, just like by function, which we can look at. So here's an interface, try function, type parameters, 3 arguments, A, B, and C, return type R. Some unspecified apply method, and then they gave a default implementation of the and then method, which does what you might expect. And it's tagged with that functional interface annotation. Then this f3c method here takes a try function, which takes 3 integers, returns an integer. Now I can basically do what I was trying to do up here. Now I actually can do it here because I defined my own try function interface. And then I get that nice syntax that I was after originally, where the 3 argument lambda looks, same as the 2 argument lambda. So the Java compiler lets you kind of, if these interfaces that the standard library provides, like function and bifunction and probably predicate and consumer and all that stuff, if those don't meet your needs, you can write your own and kind of plug into the Java Lambda syntax. So I thought that was cool. I was afraid we would be limited to lambdas with only 2 arguments, which would be totally lame.
Did you see anything when you were researching this on why they didn't do that in Scala? Because they felt like they needed to.
I don't know. I didn't find anything. I don't know if it was a statement like more than 2 arguments and you should refactor your code, or.
Well, if they probably may have done that, they would have had to make that stuff.
Yeah, I don't know. That's a good question. I don't have an answer. But I did wonder the same thing. Okay. Any other code, like Java code? Want to rewrite? I didn't write a lot of Scala code for like the stream stuff. Because so much of that is just a standard part of the Scala collections library, like mapping, flat mapping, filter, even option. I just assumed everybody knows that. Something I did kind of find interesting. So the Java collections library, there's the kind of the base interface collection. So, yeah, I would say this is not a monad. Cannot, map, flat map, filter, whatever, Java collections. But the stream stuff is very functional oriented. So it seems like as a bridge, they stuck on. So collection has a stream method now, which returns the elements of that collection in a stream. And there's also parallel stream. So I think that's kind of the bridge between like the old school Java collection and the Fox strings.
There was a lot of debate in the early days about whether streams should just be part of collections, right? They should just add the streams interface onto collections. They realized that there's a lot of things about collections that aren't functional, right? So it has things like count, which implicitly stop you from, you have to count all the objects in the stream. You basically ruin the stream by doing that. And there's a lot of things that just kind of didn't fit. So that's why they wound up basically bolting that stream onto all of your collections. So you have to, it's basically like you're opening the wardrobe and going into Narnia when you do that stream.
So you can do all the cool functional stream stuff with collections. You just have to follow that stream. So also the Scala has its own stream abstract class, which I think in a lot of ways is similar. It's meant to just be kind of a stream of elements. It's not like a fixed size collection of things. I think there are some differences. I haven't done a deep enough dive into the Scala or the Java stream to have a lot of thoughts on it. Unless anyone else has thoughts. Okay, unless anyone wants to see the Scala equivalent of like kind of stream, functional stream operations, I'm just gonna kind of go into that Spotify demo. So this is getting more into the concurrency side of things. So I don't have the full Spotify example that Ryan has. I just kind of whipped up this little fake version. So there's this case class artist record. This Spotify utils has the same methods as Ryan's code, where you can give it. I think this is kind of like sort of a file name or URL, and it's meant to simulate hitting the Spotify HTTP service, pulling back a bunch of JSON and deserializing that into a data structure. So we have the same two methods: download, cite, and then this calculate relevance, which I'm just hard coding to one here. But then that lets us kind of do the completable feature example and the parallel stream example. So just to back up a little bit with features, so feature is part of the standard Scala library now. So you don't have to use Akka to use features. Actors are still in Akka, but features are in Scala. So kind of an example where you use it. We have a method here, does something very slowly. Then we can create this value f1, which is a feature that contains a string, or that will contain a string. This is how we call it, feature pass in a method. See what's really going on there. So we're calling this feature.apply, which takes a lambda, a little function, has no arguments, returns some value of type t, which in our case, this is that little method, takes no arguments, returns a string. So something underneath the covers will, asynchronously call our method and fill in the value of f1. Features a monad, so we can map value. Whenever that string appears in there, we can map it into another feature which contains a length test. So the Java story around the two concurrency things, completable feature and the parallel streams, seems kind of opposite of the story in Scala, where the Java story is like they're not pushing completable feature, which is essentially the same as Scala's feature, but they are pushing the parallel stream. I've kind of found it to be the opposite in Scala. Maybe it's because features have been around forever, but they push features, and there's parallel collections in Scala, but nobody seems to use them very much. At least I haven't come into contact with these. Does anybody use parallel collections at all? No. So I find that kind of interesting. As a motivating example of features, here's a method called HTTP. Let's say that is actually doing a proper HTTP GET to some URL. It's returning a feature which will eventually contain the body, like an HTML page or JSON or something. We have omitted the details of this for this presentation. Pretend that we're using spray here, because now in Scala you should not do anything with HTTP except spray. Here's another method. This is hitting our database. Let's say this is some SQL string. And I don't know, whatever query that is, it always returns an integer. So these are two things that could be slow, right? We should write non-blocking asynchronous code, so don't do those somewhere else.
Just for this, is 3 question marks valid?
Yeah.
What does that mean?
It throws it on the not implemented exception, basically, when it gets to it.
It came in 210.
Not implemented there. So it's good for presentations where you want to leave out a bunch of code.
I kept its name as QMark, QMark, QMark.
That's how Scala gets around package punctuation and methods.
Yeah, so dollar $keymark is how it represents the dollar sign. Special code. So back here in SPT, it does compile because I'm sitting in my compiler. Okay, so we have our HTTP and our database methods. Now what do we do? Say our little application. First we need to go get some HTML from some URL. after we've gotten that, we need to like extract something out of it and then make a database query with that. So there's two like slow things. And then we need to do that on two different websites. So we could just write blocking code that just does like get page one, extract value, get database query, get page two. But better than that, right? Right. Asynchronous code. So first we make features. This HTTP method returns right away. Some other thread will go off and make the HTTP requests. So we hit our page one and page two. Right away, we create these features, which just eventually, whenever the HTML appears in the page one feature, we extract something out of it, make our database query. Which again, this is just stuff. And then later, we want to take these two values out and then do something like that. So with this code, we can run these two kind of pipelines, page one and page two concurrently, and eventually stuff with it. So I think that is a good use of features. So writing APIs that can do slow things, so you can do it asynchronously and then use those features. So I rewrote the Spotify example. Here's those 4 JSON files, which don't exist in MicroBase. So the first thing we do, we take our list, that list of artists. We map that list, take each one, we map it into simulating going off and hitting the Spotify API. And now I added this download site future method. That is this download site, but instead of just returning an artist record, it returns future artist record. So if we go back here, so now we have a list of futures, and each future will eventually contain artist. Then we can take that list of artist futures. We can map each future when it contains that artist record object. We can call that calculate relevance method, which again just. So now we have converted that into a list of futures, which will eventually contain the relevance artist. Then Scala provides a sequence method, so I didn't have to write it. Like Ryan had to write it. Which basically takes a list of futures and swaps that into a future of lists. So a list of futures into one future that will eventually contain a list of all the values. Original futures. Can map that list into the average, which Scala doesn't provide just an average function right out of the box. So we sum up all those relevance values and divide by the size. Yeah, right. So now we have feature, which will eventually contain the overall average, and then we can call for each, so that when that average is eventually there, we will do a side effect infer. So I think that's essentially the same thing. And it's maybe a little bit fewer characters, but it's essentially the same syntax. Here's the example of the Scala parallel collections. Like 4 lines long, and that's because I put a lot of new lines in there. Yeah, I don't know. Maybe we should be using parallel collections more. Like this is doing essentially the same thing as the futures version. So we have our same list of artists. We call this .par to convert our list into a parallel list, so that it does everything in parallel. Then we map those artists. We take each of these strings, run it through this download site. We don't use the future version, we just use plain old blocking version because now they should be all done concurrently. Then that list we can map into, take each artist, all the calculate relevance method. Then we are left with a list of doubles that were all computed concurrently. And then we can just calculate their average by the sum divided by.
Is there any difference in like how you can like recover from errors like between the two? I mean, would the futures be more recoverable?
Yeah, that's a really good point. So, like if one of these, we get a 404, or like something blows up and it throws an exception. Yeah, I don't have a good answer. I would guess that the entire operation would fail. Yeah, with a future. So a future is really I know everybody knows this, but so feature has one type parameter t, but it's not really like an option of t. It's either going to be completed with a value of type t or an exception. So it can succeed with a value or it can fail with an exception. And there, yeah, I think there are much better error handling semantics around future than there is in the parallel collection.
And in the Java completable features, there's like on failure or with failure in that as well. So you can, I believe, yeah, there's a lot of methods in it. You search for like failure, I think. So, you're searching that up. It's good.
Yeah, it's in here somewhere. Never seen it.
Might be on a base class or something too.
Yeah, but here on the Scala side, you can do things like recover. So if the feature fails with an exception, you can map it into a different feature, convert that exception to something usable. Those things kind of chain together. So I think if one of these features in here fails, well, just that one will be. So you get, if you have these 4 artists, if one of them failed, 3 of those features would be successes and 1 would be completed with fail with an exception. Then when you sequence them together, I think if any of them are a failure, just that entire feature will have that exception. Yeah, that's a good point. So aside from no error handling, this is pretty nice code. Okay, any other thoughts on concurrency stuff? Yeah, so there's a whole bunch of Scala documentation and parallel collections. So I think as to when to use features versus parallel collections, I think if you just have a big list of things you need to map and filter over in parallel collections would be great. You need to do more, have more control, better error handling, kind of lower level stuff, features are low. I didn't really look into what kind of like a bridge there would be between those two. Something interesting I found in just looking at the Java parallel stream stuff. So you are probably wondering, like, parallel collections and streams sound great, but what's doing the parallelize stuff? Well, everything's a thread pool. We found out a couple months ago. So it's the same thing. I believe Java 8 parallel stream stuff, there's a fork join pool underneath everything. But as far as I know, and what this forum thread is basically saying, is I think any parallel stream that you are using in Java 8, there's one like global fork join pool that is doing all of the executing stuff.
You can provide your own.
Can you?
You can't provide your own. You can.
This thread was saying you can't.
Yeah, you can.
Okay. Well, that's a good thing. Do you know how?
You have to get your own thread, your own fork join pool, and then you do .supply or something and provided a list or provided a stream, and then you go off parallel off of that. I found the example that I found actually another blog post that's similar to this saying you couldn't do this, and then someone provided the code in the comments for how to do it.
Okay.
And
I wonder, maybe, so this is from January of this year.
right. And
Maybe that was a late addition to Java 8 or something. Well, that's good. That's a good thing.
but it's not obvious.
Yeah.
You have to go off and get your own thread join pool.
It is also not obvious in Scala how you do that.
A fork join pool.
Yeah, you can go read this, but you can do it in Scala also. It's not as obvious as so it's features. When you call that apply method, there's this implicit execution context here. So this is where you would, if you want to run your feature on your own isolated execution context thread pool, this is how you do it. That's a pretty simple. Okay, so we won't spend too much time on this. Getting into how this stuff takes place down on the JVM at the bytecode level is really interesting. This is a great blog post that you should all read if you want to learn more about this. So as Ryan mentioned, in Java 7, they introduced this invoke dynamic bytecode. But nothing in Java used it until Java 8. The Lambda stuff is using it. I'll probably butcher an explanation as to what exactly invoke dynamic does, but it lets you do things sort of in a less safe way. Lets you specify something to call where the type is determined at runtime, as opposed to for invoke dynamic, that'll have to be determined at compile time. So it's great for dynamic languages and these Lambda things. Scala is not using invoke dynamic as of right now in the main code branch. So again, I'll probably describe things incorrectly, but Scala is generating kind of more bytecode. It's newing up more things. There's more sort of overhead involved with the bytecode that it generates for functions, as opposed to what Java is generating. If you want the full information, excellent blog post. Something I thought was really interesting. So this is a ticket on the Scala language project to use invoke dynamic for Lambdas. So the person writing this is like, obviously invoke dynamic is better to use. And if you read through, he gives some evidence here why he thinks that's the case. But if you go through and read the comments, it sort of becomes unclear as to whether invoke dynamic like really would be better, or if they should keep doing what they have been doing. So I don't think it's like a clear-cut case at this point, anyway. If Scala should use invoke dynamic, or it should do its own stuff. Yeah, so I thought that was really interesting. There's another great Stack Overflow post, which kind of gives the current state of things. So this paragraph here kind of sums up the Scala story. So plan of record is to maintain Java 6 compatibility for Scala 2.11, and depending on uptake, jump straight to Java 8 bytecode with Scala 2.12. So that's the kind of the compatibility version of the JVM bytecode that Scala is generating. That's staying on Java 6, which doesn't have invoke dynamic. Scala 2.11, and maybe jump to Java 8, which does have invoke dynamic for Scala 2.12. In the meantime, there's an experimental backend available for Scala 2.11 that requires a Java 7 JVM, which would have invoke dynamic, that will use invoke dynamic on Lambdas. And I think maybe that may become the default for Scala 2.12, but I don't know if that's like a done deal. Yeah, so that is pretty much all I had, unless anybody wants to see other code or have other questions. Okay, thank you.